And having talked about Galileo, we can now talk about Isaac Newton, who was also active in the 17th century, although the back half of the 17th century. Uh, he put forth a variety of laws that explain why objects move uh, as they do. These three laws became known as Newton's laws of motion. The first law being that an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed in the same direction unless acted upon by an unbalanced force. This basically restates Galileo's theories of inertia uh, as to say objects tend to keep on doing what they're doing. It's the natural tendency of objects to resist changes in their state of motion. This tendency to resist changes in their state is described as inertia. Given that objects tend to do what they've been doing, objects at rest tend to stay at rest, objects in motion tend to stay at motion, the question exists, when the Mars orbiter travels from Earth to Mars, will it need to fire the engines the entire way to maintain its velocity? The answer, of course, is no, because once the object gets moving, once the orbiter gets moving, it'll keep moving in that same direction. So we need to get it moving, and without friction in space, because there's no air resistance, it's not completely frictionless, of course, there's some. But because it's mostly frictionless, this object will keep moving once we get it moving. And so when we talk about inertia, we can say a number of things about it. Inertia is the resistance an object has to changes in its motion. That's the same as saying that inertia is the tendency of an object to resist changes in its velocity, that being its speed and its direction. An object won't change speed unless you act upon it, and it won't change direction unless you act upon it. This is the same as saying that inertia is the tendency of an object to resist acceleration. Changing velocity means that you're accelerating. If we're resisting changes in velocity, then we're also resisting acceleration. And inertia is a quantity which is solely dependent on mass. The more mass an object has, the more inertia it has, and thus the more tendency it has to resist changes in its state of motion. This rings true when you think about it, because if you think about any heavy object and any light object beside it, it's much harder to get that big object moving than it is to get the small object moving. And once they're both moving, say at the same speed, it's a lot harder to stop the bigger object than it is to stop the smaller object. Now, we're going to talk about Newton's second law and the third law after that. But before we can talk about the second law, we need to talk about Newton's law of gravitation. This is not one of Newton's three laws of motion. This is another one of Newton's laws. Newton's law of gravitation looks like this. And what this says is the gravitational force between two objects is equal to this number g, which is a constant, times mass 1, the mass of the first object, times the mass of the second object, divided by r squared, where r is the distance between the two objects' centers of mass. So what this says is the force of gravity between two objects is proportional to their masses and inversely proportional to the square of the distance between them. So that is to say, when the masses get bigger, the force of gravity gets bigger between them. When the distance between them gets bigger, the force of gravity drops. The g in question here is the universal gravitational constant, which is a very small number, which means that when m1 and m2 are within the range of kilograms or hundreds of kilograms or even thousands of kilograms, this force of gravity is very, very small. And basically can't be felt.